In this video, we're going to quickly go over the derivatives and using the power rule. And then we're going to do a few examples. So the power rule basically says that if n is a rational number, then we can say that the derivative with respect to x of x to the n power is simply going to be n times x to the n minus 1 power. Now this is really convenient and it makes our lives really nice whenever we're doing derivatives because it lets us get around using the definition of the derivative. So let's do some examples and see exactly how it's done. So if we have the derivative with respect to x of 7 times x to the 5th, that's simply going to be equal to 7 times 5 times x to the 4th, or 35 x to the 4th. The constant on the outside of the derivative there doesn't really make a difference. It's just multiplied on to the 5, so you can see how that works. This also works when you have negative exponents, but you have to remember that you're subtracting one from the exponent. So in that case, if we're taking the derivative with respect to x of x to the negative third, we'll get negative 3x, but then we have to the negative third power minus 1. Be very careful at this. It's really easy to make this a negative 2, however it should be a negative 4. So it's negative 3x to the negative 4th power. And you could also rewrite that, remembering our exponent rules, as negative 3 over x to the 4th. So if you have exponents on variables in your denominator, sometimes making it a negative exponent in the numerator, you can get away with using the power rule instead of using something else like the quotient rule. Now let's do one last example. So say we have f of x equals 2x to the 100th power. Well, f prime of x, also another way to write the derivative, is simply going to be 2 times 100 to the x to the 99th power. It's not much more difficult. As you can see, it just can look a little bit scary because anything to the 100th power is a little large. So that would give us 200x to the 99th power. Hopefully this can help you guys out on using derivatives and the power rule.